Good evening, all of you. So, in our previous class, yesterday's class, we have discussed about the different electronic components and then sign conventions and different power sources, means voltage sources and current sources. Today, we are going to take a little bit idea about the parallel combination and series combination of the resistances, and then go to the different theorems for the solution of the complex networks in the electronics. So series combination, example first. This is suppose that your voltage source this is R1, this is R2 and this is R3. So it is given to you that what is the value of Vs, R1, R2 and R3. Okay. So what is the main point which makes them in series, that you should write, or you should always remember that series means same current. कोई भी दो component, any two components in the electronic circuit is in series, it means they are sharing the same current. Same current is flowing through the all elements which are in series. So series means same current. So here is what the current generated from or delivered from this voltage source to this circuit is what same. Suppose that the current is I, then the same I is flowing from this R1 resistance, from this R2 resistance and from the R3 resistance. Same current, then we can call it series circuit. Okay, so the voltage drop or the potential difference occur on these resistances is what? So in yesterday class we have discussed about the sign convention. So plus minus, and what is here? I into R1, right? Plus minus I into R2, plus minus I into R3, right? So in same current, I and I, because in R1, R2, R3 resistances are in series, so they having or sharing the same current. So you can write it here what? Vi, the voltage drop on the R1 is what? IR1, V2 is what? IR2, and V3 is what? IR3. So this is what, here is what you are using V proportional to R. Your voltage drop in the series circuit is what? I सेम है इसलिए V equal to IR, ठीक है? Okay, so what you can write, that power or the potential delivered from this Vs is distributed over or shared over the R1, R2 and R3 different resistances. So you can write that Vs minus V1 minus V2 minus V3 equal to 0, that Vs equal to I times, you want to write it capital I, then you can write it Vs equal to I R equivalent, right? So R equivalent is what? R1 plus R2 plus R3. You can call it equation number 1. So in the series circuit, the equivalent resistance is what? The addition of or the summation of all the resistances in the series. And now one important thing, that voltage divider rule. Srinivas, आके बैठो. The important characteristics of the series circuit is voltage divider rule. Very important in doing calculations in the circuits. So voltage divider rule is what? The voltage drop on any one of the given resistance is what? VI. Suppose that I can vary from 1, 2, 3, right? So VI is what? I into RI. And what is this value of I? अभी हमने देखा था VI equal to VS divided by R equivalent into RI. This is known as voltage divider rule कि किस रेजिस्टिव एलिमेंट पर कितना वोल्टेज ड्रॉप होगा, that is what voltage divider. Voltage divider rule is only applicable in the series circuits. Okay, so here take example. एक एग्जाम्पल लेके देखते हैं. Suppose that a circuit is given to you, 24 volt, 30 kilo ohm, 60 kilo ohm, and here is what? Minus 9 volt, right? So by applying the voltage divider rule, what is the value of X here? तो ये क्योंकि आप देख रहे हैं कि there is no branch here through this X to share the current. So the same current, if the current is flowing through this circuit, then the same current I is flowing from the two 30 kilo ohm and 60 kilo ohm resistances. So our concept that the same current is flowing in the series circuit is true. So we can apply the voltage divider rule here. So what is this? 24 minus X divided by 30 into 10 raised to power 3, same current, right? X plus 9 divided by 60 into 10 raised to power 3 equal to 0. And by solving this, (13 volt). So you can call X equal to 13 volt. So this is the way to deal with the such kind of the series circuits and apply the voltage divider rule. तो यहाँ पर मैंने क्या किया है, 24 माइनस एक्स, मैंने ये माना है कि करंट्स जो है वो सीरीज में सेम रह रही है, उसी करंट की वैल्यू लिखी I1 इक्वल टू I2. सपोज यहाँ पर I1 मान लिया और यहाँ पर I2 मान लिया और उसको इक्वल कर दिया. Now parallel combination. SS. तो अभी आपने देखा कि सीरीज कॉम्बिनेशन में वोल्टेज डिवाइडर रूल लगता है, तो पैरेलल कॉम्बिनेशन में करंट डिवाइडर रूल लगता है. पैरेलल कॉम्बिनेशन, सपोज दैट हियर इज ए करंट सोर्स R1, R2, R3, right? And the current IS, I1, I2 and I3. तो आप यहाँ पर क्या देख सकते हैं? What you can see here is the all three resistances are on the same potential difference, because what I can assume here is 0. then what is here? 0. What is here? 0. Suppose I assume here x, then what is here? X. What is here? X. So all R1, R2, R3 resistances are in between x potential difference. So in parallel combination, same potential difference. Okay. So what you can write that Is is what? I1 plus I2 plus I3. Whatever the I coming out from this source, current source, is delivered to the R1, R2 and R3. So Is is what? V1 upon R1 plus, इसे V कर देता हूँ, V upon R2 plus V upon R3. I use the property of the parallel circuit or parallel combination, V same for all the three, x, 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 0 to x, you can call it V here, right? So this is what Is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. This we can treat this as V into, R equivalent. So now current divider rule. Only applicable in parallel combination. What is this? II is what? V upon Ri. Because V is same for all, II means the current flowing through any ith resistance is what? Inversely proportional to the value of that resistance. And you know that current is lazy. Electrons are very lazy. Electrons flowing means current flowing. So electrons are lazy means they will choose that path which is which found or encountered the least resistance. वो हाई रेजिस्टेंस वाले पाथ की बजाय लिस्ट रेजिस्टेंस वाले पाथ को जो है वो प्रायोरिटी से चूज करते हैं. सो I1 इज व्हाट? इनवर्सली प्रोपोर्शनल टू दिस Ri. एंड व्हाट इज दिस V? Here we can write from equation number 1 that Is into R equivalent. So I can call it IT, I total, where I can write that IT is what? Total current entering in parallel combination. Right? So series combination, voltage divider rule. Parallel combination, current divider rule.